Avery and any student who needed to see implicit differentiation review, page 160, number 105, worked out. I posted worked out solutions, but it's pretty complicated, so I can understand why you need to see a video. This is the equation we've been given, the expression, the square root of x times y equals x minus 4y, and they are asking for the derivative, dy dx, which is, or y prime. I'm going to use y prime. So notice the complicated part is right here. I wrote the square root to the 1/2 power. So notice we're going to have a chain rule. We're going to be taking the derivative of anything to the 1/2 power and then multiplying it by the derivative of the inside function, which is a product. So it gets a little complicated. Now the right hand side I think is pretty easy. I think you'll agree. And of course the book, actually, their answer looks like this, which won't look anything like our answer for a little bit. So let's take the derivative of both sides with respect to x. That means I'm going to bring the 1/2 out front and multiply it and reduce the exponent by 1. That's a negative 1/2 exponent. So let's bring the 1/2 out front. And now our exponent is a negative 1/2. I'm going to show it as a square root in the denominator of the inside function. And then we have to multiply by the derivative of the inside function. Right? So this is a product rule. So I'm going to talk my way through the product rule. And I'm going to use parentheses here. The derivative of x is 1 times y. Plus I'm going to keep my x and multiply it by the derivative of y. So again, we brought the 1/2 out front and multiplied it, reduced our exponent by 1. That was a square root in the denominator of the inside function. And then of course we never took the derivative of the inside function, so we did that here with the product rule. Okay, equals. Now the right hand side, the derivative, much easier. The derivative of x is 1. The derivative of 4y is 4 times y prime. Okay, the next thing I'm going to do is get all the y prime expressions together and on one side of the equation, and all the expressions without y prime on the other side of the equation. This means this y prime is stuck in parentheses, so I am going to distribute the y to the first expression and the x times y prime. So let's go ahead and do that. Notice y times this expression is a y in the numerator times the rest of the expression plus the derivative of this expression here would be, I'm going to put the x in the numerator. There we go. And times y prime. So notice I have this product times this here. And that would equal, I'm not going to change anything on the right hand side. Okay, so I am going to get my y primes to the left and anything without a y prime to the right. Okay, so this means I'm going to add a negative 4y prime, and I am going to subtract this expression so that it is on the right. So here we go. I'm going to add 4 times y prime, and this term is still on the left hand side. There we go. I have this one and this expression on the left. On the right, there's a 1, and I will subtract this expression. There we go. Now, because I only have y primes on the left, I can factor it out and write what's left. And the right is still not changing. There we go. So to get y prime alone, all I have to do is divide by this expression here. I'm going to come on down here. we go. So when we're done, what we have is y prime equals this totally ugly expression right here. It's true. It's true. But when you look at the back of the book, this is what you see, and you're like, what is going on? How is mine so different than theirs? So here's what we're going to do. I have one complicated fraction divided by another, and so I'm not real good with how it looks, but if in the numerator I could get a common denominator, and if in the denominator I could get a common denominator, then I would have one fraction divided by another, and I could multiply by the reciprocal. So I'm going to try that. So if it's okay with you, this expression that I have here is y prime. So you won't see it over here, but I'm going to be solving for y prime. Y prime equals this. I'm just going to be working with this. So here we go. In the numerator here in this black box, my common denominator would be 2 square roots of x times y. So I'm going to multiply the top and the bottom of 1 by that. There we go. There's my numerator in the black box. In green, notice I need a common denominator of the same thing, 2 square roots of x times y. I'm going to multiply 4 by that expression. And that's plus, there we go. There we go. So now my numerator has a common denominator, and so does my denominator. I'm going to write this as one fraction in black. There we go. There's our new numerator with a common denominator. And in green, I'm going to write that new denominator. All right, there we go. So pretty complicated, but common denominator here and here. And all I did was write it like that and do some math in these numerators here. Okay, well, since I have one fraction here, one fraction here, I'm going to do this in blue. I can multiply by the reciprocal. Just got to flip this over, talking to myself a little bit, keep things straight. There we go. Did I flip that over? I sure did. And there we go. This is the same problem. Notice these cancel out, and I am left with 2 square roots of x y minus y over 8 square roots of the square root of xy plus x. Okay, so this looks much better, but you may say, well, Ms. Culver, it doesn't look like this at all. This is what's in the back of the book. That is because when you start seeing that you really felt you did something right, but you are way far from what they had, they did something to simplify it. This happens a lot with second derivatives. This isn't a second one. But let's go back to the original problem. Do you see they are telling you here that the square root of x times y is x minus 4y? That's the square root of x times y is this. So do you see right here, this square root of x times y is x minus 4y. So I am going to substitute. That is where the square roots went, x minus 4y. Right here, this is x minus 4y. By this point, you're probably like, oh, so let's take a look. I'm going to distribute here. And here, this is 2x. This is minus 8y minus y. So I have minus 9y's. And in the denominator, this is, I'm going to distribute the 8. 8x plus x is 9x. And this is minus 32y. There we go. So it was a real trick right here that they kind of had going on, but when you do a lot of calculus, you start seeing that pattern. So I hope that helped. It's a pretty complicated problem. Have a great day.